So I'm going to be talking about why bees use hexagons when building honeycombs. So first, here we have the area of a hexagon formula. This is going to help us prove that this hexagon is equal to this little cluster of triangles. So we use the derivation of the area formula to help us prove that. So we have a half times base times height to get the area of this triangle times 6 to equal all the triangles up. The base is the side length, which is 2, which is not really important for this problem. But so we have a half s times square root of 3 over 2s, which would equal to square root of 3 over 4 s squared times 6. You get square root of 6 over 4 times s squared, and that simplifies to 3 square root of 3 over 2 times s squared. So we've proved that this is equal to that. Now, the important thing to determining why this, as he is stating, is an inefficient use of materials is the fact that it's made of multiple triangles. So we need to get the perimeter of all these triangles added up and the perimeter of the hexagon. So 6 sides all equal to 2. 2 times 6, perimeter is 12. But with this, there is 6 triangles and 6 sides all equaling 2. So that would equal 24 as perimeter. They'd have to use double the materials to make this. So that'd be an inefficient use of materials. While it's the same amount of space, no materials, so undesirable. Which is why the hexagon shape is most effective for building honeycombs.
Hello, my name is Nathan Cloninger. This is my Math and Nature video for Math 172. Today we'll be trying to find the mass of a tree, given that it is a pine tree, a longleaf pine tree. They're all uniform, they all grow at the same rate, they all grow at 1.5 inches per 10 years. There are 40 trees in an acre, and they grow at ½ a foot per year in total height. Now we got to find the radial growth. So what we do is we denote it as RG. Radial growth is how much it grows out from the radius. X is the number of years after sampling stage, and this is our formula to find RG. Then what we do is we find the total height. Total height is a similar formula, however, it grows at ½ an inch per year. Now, our diameter growth is based off of 2 times the constant for pine trees times RG. Now we multiply that in, we get 2.12 RG is equal to the diameter growth. Now, radial growth does not take into account diameter, is why we add this extra. Now, let's move on to total. Total weight is equal to this formula. It is a long number by d squared, or radial, same as our diameter growth, times total height. Now, we input our formulas for what we can find in there. Then we simplify it into this formula here. Now, if we want to find what x is, or if it's 65.5 years, and we let it grow, and we want to know the weight of all those trees, then we find that each tree is 2,839.5 pounds. Well, there are 40 trees, so we just find 40 trees per acre, multiply by 40. And then for the mass, we convert it to kilograms to find mass. We get 0.4539 kilograms times that, pounds cancel out, and we get 51,519 kilograms per acre. Now, if you have a forest, you have large amounts of forest, how do you find out the weight of all, the mass of all that if you want to know? Well, what you do is you just multiply that by the number of acres in the forest.
Hello, today me and my partner Aiden May will be discussing marginal profit for our Math 263 class. A real-world example of marginal profit can be shown by problem number 19 from chapter 10.9 in our class textbooks. In this problem, we are looking at the cost of producing X amount of cell phones, and we're trying to find the marginal profit. We are first given our R of X and C of X functions. For our R of X function, we have 94x minus 0.03x squared In our C of x function, we have 10,800 plus 34x. We are first told to find P of x, which is our profit function. To find your profit function, you will first subtract C of x from R of x, and once doing so, you will get negative 0.03x squared plus 60x minus 10,800. Now that you have your profit function, you are told to find the marginal profit function, which can be demonstrated by P prime of x. To find your marginal profit function, you'll take the derivative of your profit function. Once doing so, you'll get negative 0.06x plus 60 minus 0. Of course, that does not count, so your marginal profit function will be P prime of x equals negative 0.06x plus 60. And once related back to problem number 19 from our textbooks, this will be the marginal profit for producing X amount of cell phones, no matter what that value for X is.
Hey everybody, so as Kylie just explained that math and the marginal profit and the profit function are really important in a lot of people's lives, all across America and all across the world. A lot of businesses use this a lot, and really that's kind of why I'm taking Math 263, to be able to use these functions like this later on in my life and in businesses and different classes that I've taken. Just from taking other business classes, I've seen how this can be used. The profit function, the revenue minus the cost equals the profit. I think it's really important. So to find that, we just take the revenue and subtract the cost function for it. And then to find marginal profit, we get to find like profit rate, like how it's changing at a certain amount. And I think this is really important too, just like how businesses and different people can see like how different profit margins continue to change, and they want to know like if their company is making money or losing money. So as a business owner, it's really important to know like, okay, how much money am I making over the course of this year or the course of the month? So this function is, like I said, used by many people all across the country, all across the world, and business owners get to see how much money they're making or how much money they're losing, so they can know how to run their business smoothly and keep it on the right track. So thank you.
My name is Carson Hannier,
And I'm Zoe Gonzalez.
and our math and innovation project is on compound interest.
So a little bit more about compound interest. It is used to find how much more money is either gained, which is also known as an investment, or lost, which could also be known as a loan. So our compound interest formula is A is equal to P times 1 plus R over En raised to the N times T power.
And A is represented by the future value of the investment or the loan, and P is represented by the principal of the investment or the loan, which is the initial amount, and then the annual R is represented by the annual interest rate in the decimal, and then N is represented by the number of times of interest is being compounded, and then T is time in years.
Alright, so our problem that we will be solving today is a college student borrows a total amount of $140,000 with an annual interest rate of 5.8%. However, the interest rate does not start compounding until after the student graduates. What is the college student's debt 4 years after graduating? Come on.
Our principal amount is $140,000, and then our rate is 5.8 divided by 100, which is 0.058. Number of times it's being compounded per year is only 1, and then the number of years is 4.
Alright, so if we come over here, this is solved out. So we are trying to find our future value. So we don't have anything for A. And then since we have all the other values implemented for the P, R, N, and T, we can just put them in the formula. So 140,000 times 1 plus the annual interest rate in decimal form, which is 0.058 over 1 raised to 1 times 4 power. So 0.058 divided by 1 is just 0.058, and you add 1 is 1.058. And then 4 times 1 is 4, so it'll be raised to the 4th power. And you would just, in your calculator, put 140,000, parentheses, 1.058 raised to the 4th power, and you would get a whopping $175,416.61, which would be the debt 4 years after graduating.
Thanks for watching.